Hey everyone, today we're going to be going over unit testing in Go, and we're going to be using the standard library to do so, most notably the testing package. So right now we have just this simple main package with a main function, and as you can see we're importing this divide function from the foo package, and it has a result in an error that it returns. If it hits an error, we're going to simply print the error. Otherwise, we'll print the result to 2 decimal places. And as you can see, it's just a format printf, so it's just printing the string with the format string. So we'll look at our Go version first, just to make sure we're on the same page. So we've got Go version 1.23.2, and then I'm going to run this program. And as you can see, it returns 5 to 2 decimal places, and 10 divided by 2 is 5, so everything checks out. Now, if we look at our foo file in the foo package, we'll see we just have that divide function that we called. Takes 2 parameters, which are both floats, and then we have the float and error tuple being returned depending on how our function logic handles it. The only case when we'll have an error in this function is when b is set to 0, and that's just because there'll be a divide by 0 error that will return, and it's just a custom error writing with this error string that we created. Otherwise, we'll just return the quotient of a divided by b and have nil for the error. So what if we wanted to test this function instead of running it from the terminal to manually test it? So we'll want to create a file right next to the foo file in our package, and we'll simply name it the same name and then _test.go. And then for the package, we'll want to do package with the same name as foo, but we'll add _test as well. And then here we can import the foo package and the testing package, and we'll write a simple unit test now for that divide function. Now let's just write a func here to test divide, and we're going to pass this t parameter, which is a pointer to a testing.t, which is a struct from the testing package in the standard library. And it's basically just going to provide us with extra support for running tests. So we'll implement this unit test similar to how we wrote the main function. So we'll just say results and error is equal to foo.divide of 10 and 2. If the error is not equal to nil, we'll have a fatal error. And all a fatal error will do is stop the test immediately. And then otherwise, we'll just do a results check and make sure it's equal to 5. If it's not equal to 5, we'll just log this error as well. And we'll close our unit test function and save the file. And as you can see, we're going to write that we expected the value of 5, but instead got this result if it doesn't return correctly. And the error f function is simply just logging f followed by a fail. So it's doing fail instead of fail now, whereas fatal is doing a fail now, but also logging as well. Now let's run this with go test. But notice how it says there's no test files. Now you may be wondering why this happened, because clearly there's this foo test file in this foo folder here, and the reason for that is Go does not check recursively for test files. So instead you have to go test with the dot and then a slash and then 3 dots, and that will recursively go through the entire directory from where you currently are in your terminal. So if we enter this, we'll see that it's now running this and succeeded with an OK value. Now what if we were to change this to error out if the result was equal to 5? So we should expect this to now error. So we'll run the test all over again, and we'll see we get a fail here. And if we scroll a little bit, we'll see that it says the test divide function, as we wrote here, is failing. And you'll see that it's on line 15 where it expected 5 but got 5. And that's only because we changed this conditional logic to be incorrect. So if we change it back to this, we should rerun our test and it'll be okay again. And that's what's nice about Go, is you can have these unit test files right next to the actual file where the implementation lies. So it's easier to navigate when you're developing it. And then when you run the Go test with the recursive option, you'll see that it nicely splits it between the package you're in. And another great thing about Go is it'll cache the tests if nothing is changed in that specific package. So that way it'll save you time if you're running much larger, longer tests. So what if we had several things we wanted to test? For instance, in our divide function, there's multiple things that could occur. We could have a divide by 0 error as well that we're not testing here. Now, we could write an entire other function for it, or instead we can do a subtest. And for that, we can just do a t.run, and then we'll have a divide by 0 section, and we'll just check this here. And then we can split this one into its own t.run, which is divide by non-zero. And move this into here, And then you'll see our function is now split into two subtests. And if we hover over t.run, you can see it just runs a subtest of t called name. So if we run the same test again, we'll see that it's okay. However, if we were to change this to 1, so it's now a valid, it's not divided by 0 anymore. So this should now error out because the error should not be nil. We'll see that the divide by 0 is now erroring out, expected error but got nil. And you can see it's a subtest because it has test divide and then the specific subtest within it, which is divide by 0, as we wrote here. Now let's change that back to be correct and then run our test again, and we'll see everything's working. So this is a great way to divide the tests, and I feel like it keeps your tests clean. However, there's also a way to further refactor this test, and this is a technique called table-driven tests. So what if we had a bunch of these t.runs within a single test, and they were all performing a similar type of operation, but with just different edge cases? We can actually refactor this entire section of code to iteratively run over all these edge cases. So we can represent the table as an array of structs in Go. So we'll create this using a var tests, and we'll set it to the structs that are defined by a name with a string, which is the name of the subtest, the A input, B input, and what we want our result to be. And for that, we'll just do result float 32, and then we'll have an error as well, depending on if we expect it to return an error or not. And then we'll define this so we can have a valid and invalid. And in that case, we have 10 divided by 2, which should be 5, and then it'll have a nil error. Otherwise, if it's invalid, it should be 10 divided by 0, which in our case, an invalid one returns 0, but it also returns this error value that we're checking. So now we can iterate over these subtests. And for each one, we'll run with the test.name and then the function. And then we'll get the result in error of foo.divide. We'll check if error is equal to nil and test error is not equal to nil, we'll have an expected error. Alternatively, if the error is not equal to nil and test error is equal to nil, this should also error out. And finally, if the expected result is not equal to the result in this test, we should also error as well. And now if we run go test, we'll see that it's okay. That means that this iterated through both of these tests here and successfully ran both. We can validate that this happened by changing both of these to fail. So we'll say 10 divided by 1, and now change this to 0. So now neither of these should succeed. We'll run both, and we'll see that for both of these, we had our valid subtest and our invalid subtest both fail. So we'll change those both back and rerun it, and it's back to passing. Now, these table-driven tests are useful, especially as the number of edge cases increase or the number of things you want to test in each function increases. Because if you have like 10 of these, it's a lot quicker to simply write this table-driven test than write out each of these subtests individually. And now that we have this test passing, let's go ahead and look at the code coverage, which means how many lines of code in this foo function that our current tests are covering. So if we go back and look at our foo function, we are testing this edge case and this edge case. So we can simply write go test and add the cover flag and then pass the path with the recursive option. And we'll see that it has a coverage of 100% of statements. So this entire foo package is completely covered. And that's just the case because we have this simple divide function. That's it. If we were to add another function like multiply and return A times B, and run go test cover again, we'll see it's only 75% of statements, and that's because this function is not covered by a test. Same thing would be if we added another check here and then returned a cannot divided by 0, or we'll just name this extra check. And we run our coverage again. We'll see that it's only covering 80% because again we added this extra line of code that's no longer being covered in our test. There are other features to the coverage testing as well. You can use a cover profile and set it to an output like out.profile and do the recursive, and you'll see that there now is a out.profile. So if we'll cat it out, we'll see that it has this output file that's describing the testing coverage. And this is useful when you're using other types of code quality tools, especially in CI/CD pipelines. And the cool thing about the cover profile that Go also includes is a way to output this to a formatted HTML report of the code coverage. So to do that, we'll do go tool cover, and we'll set the HTML equal to the current path, which is the out.profile. And then we'll set the output to be the coverage.html. So now you can see this coverage.html file was created. And if we go and view this in our browser, we'll see here that we have this code coverage page, which is showing that it's covered if it's highlighted in green. And this entire divide function is being covered in green, which means it's all being covered by the tests. If we go back to our main.go, you'll see this is in red, which means it's not covered. And if it's not being tracked, which in this case is something that isn't relevant to testing, like the function definition or the package and import statements, then it'll be grayed out. So there are some quality of life functions in the testing package that make writing tests easier. For instance, if you wanted to have a shorter or smaller subset of tests, you can just write a if testing.short block, and then you can write a t.skip to skip tests. So whenever you run short mode for the tests, it'll skip any test in this testing.short block. And you can see this short reports whether the test.short flag is set when you run it. So otherwise, we'll just run the actual test. So we'll just check if the divide by 0, for instance, is erroring out, and we need to add the foo package, and we should expect an error or not. So we'll run go test, and we'll see it runs it successfully here. But in fact, we want to check if it fails to ensure that our test is failing. So we'll see it failed here, and then we'll skip this test by running the short parameter. So we'll do a test.short flag, and we'll see that it skipped it, even though it just returned an error. And that's because it's hitting this block and skipping the rest of the test. So it's the equivalent of logging and then skipping. So if we were to add the verbose flag, we'll see that we get a run, and that it skips a test in short mode in the skip, which means it passes the failing part of the test and returns OK. There's also the idea of parallel tests, so you could run two things at the same time instead of sequentially. So say we wanted to divide by 0 here, and then we also wanted to have the t.run just for the normal divide, and then we can add t.parallel here to each of these subtests, and these should run in parallel now. So when we run, we're not going to notice a difference, but we'll see that this ran. If we add a sleep, we'll sleep for 3 seconds in each of these just to test out the fact that these are running in parallel. So if we go test, we should be sleeping. And after 3 seconds, we see both are done. We remove the parallel now, comment it out, and go test again. We should expect this to take 6 seconds because it has to run each of these sequentially. And we'll see that it now takes 6 seconds. So it's nice, especially when you have a function that takes a long time to run. Although it's good to ensure that you're using it correctly, because there's some cases where parallel could cause issues. So I'd recommend reading more into it before you use it in your tests, just to ensure that it's not going to cause any issues. There's also a temporary directory helper. So if you have to do any file I/O, instead of manually creating and managing and deleting your temporary directory during your tests, there's a nice helper function. So you can simply create a tempter, set it to be the t.tempter, and then if we just log this, so we can do t.log, and we'll just output the path of the tempter, and when we run this test with the verbose flag, which is tacv, we'll see that in the foo test, we have a tempter at this temp location, and now that the test is ran, we'll just ls it to see if it's still there, and we'll see it cannot access it because it no longer exists. And if we go backwards, still can't access it. So this has been created and deleted automatically for us, which is very convenient. And the last helper I want to go over is the t.cleanup. And this is just a helper function that runs when the end of a subtest or test is complete, depending on where you're calling it within the test function. So if we just run the t.log of test cleanup here, we'll see after the test runs. So we'll add a test start and test end between t.cleanup, and this will just show that cleanup will still run after this log function of test end finishes. So if we run go test again, we'll see that we get test start, test end, and then test cleanup afterwards. So these are the primary unit testing concepts in Go. I kept it pretty simple and trivial in this video just to demonstrate the concepts as well as I could. There's a lot more to the testing package within Go. I only covered a small surface, and I only went over unit testing. There's a lot more to testing than just unit tests, and it's something that you should definitely look into if you're looking to adequately test your program. Anyways, I hope you guys found this video useful, and I look forward to seeing you in the next one. Thanks for watching.